Not it's
Till
not very recent now, but you are right. It was not the case.
till grade 2, we were learning that it's a planet. Okay, done given that then.
So let's put the definition. In this chapter, you just mainly need some definition. There is only one topic which is relatively big. Otherwise, this is an introductory topics. Dwarf planets, body other than dwarf planet, other than a natural satellite moon that orbits the sun, and that is for practical purposes smaller than the planet. So they are other than the moon, and they are orbiting the sun, but they are not very simple. Dwarf is like a moon, but it is orbiting the sun. It is not a it is not of the size of a regular planet. It was a planet, but later we discovered that it is not fulfilling all the conditions of a planet. So dwarf planet is actually like a natural satellite. Moon is a natural satellite, but moon is orbiting, our moon is orbiting the earth. There are other moons also. If a natural satellite thing is orbiting the sun, then it is called dwarf planet. You have to copy this.
I can write dwarf planet is a natural satellite that orbits the sun. Okay, done.
I missed your question.
Nothing, sir.
Actually, I missed your question. There was a bit lag. So you were asking a question. I missed it.
I said, but this one I can only write that till the dwarf planets are a natural satellite that orbits the sun in the exam also, right?
No, you have to copy the whole now.
Oh, oh, okay. Okay, done. Done.
Okay. Now we are putting our next concept. Pluto, it is now in our, it was the latest thing which we changed about Pluto, that it is now classified as a dwarf planet. So the Pluto is not a member of our family as a planet. So now, initially there was only few, but now they have discovered that there are many other dwarf planets which have been discovered, which are away from the sun. Now, there are 8 planets, an unknown number of dwarf planets. So the gravitational field, how they all are orbiting, how all of them are orbiting the sun. The answer is a gravitational force of attraction. The main force is gravitational force of attraction, which is holding every other object. So why all of these planets, dwarf, comets, and they all are moving around the sun or moving around a system. The source is gravitation. Newton was the first person who presented this remarkable idea that gravity is the source of attraction for everything. So our planet is orbiting the sun, moon is orbiting us, and our artificial satellites are also orbiting the earth. There are many things which are orbiting the sun also. So we have a concept here that gravitation is actually holding everything in the universe. Now, sorry, you have to write under it a single sentence. Gravity is holding every object in the universe. So write under it. Gravity,
Copy this whole thing.
no. Just I'm dictating. Gravity is
That
holding every,
is holding every thing in the universe.
gravity is holding
What's
every,
the next? Okay, the universe. Okay. I can't hear anything.
gravity is holding every object in the universe.
Okay.
So now what is a dwarf planet? Dwarf planet is actually a planet which is not having sufficient gravitation. It is not having the properties like other planets. So it is a type of subsidized planet, and it is not able to attract objects towards itself properly. Now, asteroid is a very famous character in many movies.
Yeah.
What is an asteroid? They
These
are,
are
look at the diagram. I hope you can see this diagram or you have seen this. These are rocks. In simple terms, Hamad, these are big, huge rocks. And again, gravity is a miraculous network which is holding so many things. But have you ever heard about those stories that an asteroid will hit the earth, or it has taken a collision in past and it can destroy everything? Have you heard of those movies or any story like that?
I have seen movies.
Hmm. So this is one of the famous space stories that asteroids are some very small, some very big. We have some scientists had a belief that dinosaurs were uh, also died by this. So actually they are capable of hitting something, but interestingly, their orbits are very unique, and we are still lucky that we didn't get hit by any major asteroid. So now you have to copy this screen.
How will the asteroid reach the Earth planet surface?
No, our planet is open, Hama, is open from the top and every other side. So it's just like you are moving and you bang into a car.
Until it comes to the land, that will shatter into small pieces.
Can you repeat?
Until it comes to the surface of the land, it will shatter into pieces because of the atmospheric pressure.
But you're right. But if it is too big, then the problem will occur. Na? It will definitely atmosphere will burn down it, but it will turn into pieces. It will be an asteroid rain of stones.
Okay, Faisal.
Okay. Now, there is an asteroid belt in our solar system, and there are many asteroids in this region. It's just like a asteroid, just like a marquee of asteroids. So many asteroids are in that range. As I mentioned, it's a gravity equilibrium. So these asteroids are following their orbit. Some of them get close to Earth also. Now we talk about moons. You have to give a side heading, moons.
I don't need to write that.
No, no, you do not need to write everything.
Okay. Okay. Done.
What are moons? Moons, there are just like in our system, Earth has one moon, Mars, Jupiter, Saturn, Uranus, and they all have their moons. We have luckily only one moon. So at least one moon is there. So disputes are there, but at least one moon is there. But some planets have multiple moons, and the moons of Jupiter. Look at these are the moons of Jupiter. So moons are, what is a moon? How we can define a moon? Moon is a natural satellite. So now
That
you have to
orbit.
give, after giving the heading right under it.
It is a natural satellite that orbits the planet.
Yes.
I'm really confused how the past paper of this topic will be.
Past papers are not very simple. MCQs are simple, but theory questions are not simple. This topic is not so simple. Actually, it's a new topic, na? So it's a evolution topic. Evolution for students, evolution for teachers. But as compared to electromagnetic induction and other topics, it's not difficult comparative to that. Comet. Give us side heading comets.
Okay, sure. Done.
Now, what are comets? They are actually frozen planets. They are deep freezers and they are like a frozen ball. If you have a chance of going through these ice areas where you can throw snowballs on each other, they're very unique places and it's a very fun of using ice as a snowball. So these are frozen units. Interestingly, they melt also because when they come to and they receive the sun heat, they melt also, so they are cosmic snowballs. So what is a comet? Comet are made of dust and ice and orbit the sun in a different orbit than two planets. When they pass close to the sun, what happened? The ice melt. So after giving the heading comet, you have to copy this. Have you copied?
Yes, sir, done copy. Sir, can you give me a minute? I'm just coming back.
Yes, are you back?
Okay, sir, I'm back.
Okay, so we had made a discussion on asteroid and comets. Now we are moving to our next title, satellite. Moon is a natural satellite. So when humans observe the motion of the moon, they thought if moon can orbit the earth, why don't we send our artificial satellites? Is a very big desire. And what was the objective of using this very expensive technology? It was a idea that you can sit outside a stadium. If you sit outside a stadium at a far focus, you can view the stadium as a whole. Otherwise, you can't see it because you're part of it. So it was the idea that sit outside the earth at a far focus as a distance, and you can collect information about the earth very effectively. So you have to give a heading. You have to give a heading satellite.
Okay, sir, given satellite.
A natural satellite is any celestial body in space that orbits around a larger body. So we have an artificial satellite and we have a natural satellite. Artificial satellite is actually man-made, and we have sent them. Natural satellite is the moon in our knowledge, and we actually copied. Humans have copied the technology of the moon that is
So
being
the
used
natural
to.
satellite is the same thing.
Sorry.
The moon and a natural satellite is the same thing.
Moon is a satellite. Moon is a satellite, but it's a natural satellite.
I know that moon can't be moved, but if moon is not there, then the satellite can work as its second option.
Can?
It can work as second option instead of moon.
No, actually, I didn't get you. Can you repeat the question, please?
The moon is used as a light source for the night, right?
Right, right, right. Moon is a source of light. I
The
think
moon, the,
China has made China has made or planned to make a artificial moon, and this is used for
it
as a
was a
source of
rumor.
light.
Some people told it was a rumor, and some told that it was real. I don't know.
I have heard it, but I didn't confirm it. Actually, Chinese can do a lot of things, but sometimes the thing is under progress and something it's ready. But
They don't have a warranty.
but one thing is there. One news is confirmed that China is successfully moving towards artificial sun, which is a much bigger target, that you can produce an artificial sun which can produce huge amount of energy by using nuclear fusion. So this is an idea that this is a confirmed news. But I have heard that they were
Okay, sir.
planning to make an artificial moon. That moon can provide light in your cities in the night time, so you can
There's a
save
lot
money
of
on
lag in the
using
voice.
city lights. Okay, now you have to copy this screen. Let me know once you have copied it.
Yes, sir, done copied. Yes, sir, done copying.
So we have two types of satellites, natural and artificial. Moon is a natural satellite. Artificial satellites are man-made and can orbit any object in space. Now NASA and other sources are confirming that there is a huge number of satellites. So look at this family fully loaded. We have planets, we have asteroid, we have artificial satellites, natural satellite, dwarf planets. So it is actually a very crowded system. Our solar system is fully crowded. Now, in comparison, just like if you see, there are four planets nearest the sun and rocky and small, and the four planets which are away from the sun are gaseous. Now, it's a very technical concept. Gaseous planets. Actually, our planet was also in a gaseous way, but later it stabilizes, and now it's by now it is the only available living planet we have. So this is an aggregation model. So we are starting this concept. You have to copy this screen.
I should write the whole thing.
Yes, you have to write the whole thing.
Okay, done.
Right. Now, accretion method. This is actually a model which defines some members. The model depends on gravity. This is the first point. Now, what is the meaning of this first point? The model says, this is actually powered by Newton. The model says that every planet, every draft system, everything is moving in the space, but none of them are bound permanently with the sun. So who is actually holding them? This is the gravity. So you have to copy this. Yes, you have copied it. Mark, can you hear me?
Yes, done copy.
Okay. So what's the meaning of this concept? Every system in the space is actually surviving due to gravity. Gravity is providing centripetal force. Gravity is providing the pull of gravity, that is the weight. So scientists now believe that gravity is like a carpet which is spread over the universe. It's everywhere. This is the first point. Now, the model says the presence of many elements in internal interstellar cloud of gases and dust. So there are many elements like sodium, potassium. So it's a huge family, even though still it's a mystery that how water came here, but definitely the elements are present. Elements are present in good number. Acha, copy the second point.
These both are only the second point.
Third, the rotation of material in the cloud and the formation of an accretion disk. You have to copy this.
For all of these, right?
Hmm. It is they all are the postulates of the accretion model.
Well, these are important points, right?
No, 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 no. I will show you the past paper questions. In this chapter, they ask a bit strange questions, not just like a full detailed things. So normally there are calculations and there are some sideways questions. I will show you. First, we complete this chapter. Star formation will come is coming up. That is the topic which should be done in full length because that is their favorite topic, star formation.
Yes, I will learn.
Planetary data. This is a difficult question when it comes, they give you a data sheet related to orbital distance, orbital duration, time period, I mean, density, surface temperature, maybe uniform gravitational field strength at the planet surface, like this. This is a data. They can ask you questions under the data sheet. These questions are very tricky. During the paper, sometimes people do not follow the question very strongly, so they can trap anyone. So give the heading planetary data.
Planetary data. Oh,
You have given it.
yes. Okay, done. Planetary data.
Okay. So then you have to copy this list. I'm just coming, copy this list.
So what are main things in the Hubble's law? And then copying this. Then done copying. Can you hear me?
Yes, sorry, I had to go to washroom. Sorry. Have you copied it?
What are the important things in a Hubble's law? Because they asked me to make a presentation on it.
Hmm.
So, like, what can I include in Hubble's law chapter? The part of it.
Hubble's law is a part of this chapter.
Yeah.
So we are reaching towards it. So let it come. Hubble's law was related with the idea. It's again a very big thing, and you must have heard about the. It's now a proven theory, the Big Bang. So Hubble's law is now a very standard law. It relates with the idea that our universe is expanding like after a blast. But we are reaching towards it, so we'll inshallah do that. Give the heading gravitational field strength.
I need to draw the diagram too.
No, it's only the heading gravitational field strength. Now, what is the concept? It is just like the signal strength. When you are in a Wi-Fi field, your mobile phone can show you a signal strength of the mobile phone. The mobile phone can show you the signal strength of Wi-Fi signal. Similarly, gravity is a field. It has a strength. Strength means it has a particular force per unit mass. Definition is there. It is the gravitational force per unit mass. It is just like putting a mobile phone in a field of Wi-Fi, and mobile phone shows how much signal it is receiving. So when you put something in a gravitational field, it experiences some force. That force is called gravitational field strength. Have to copy the definition. This is the definition. This is the formula. G is equal to F upon M. Look at the mass, which is the source mass, is applying a force on a point mass small m. G is called gravitational field strength. And the unit of G is Newton per kg. G was in our O level also, basic O level initial chapters. Chapter number 2, perhaps. It was there in our chapter 2 also. So G is actually Newton per kg. Look at the formula. A big mass M is applying a force F on a smaller mass. Now you have to copy this screen. Hmm.
The same formula is there in the starting of chapter 2, right? Gravitational.
Sorry.
This formula is, we studied this formula before also.
Ah, this formula is actually weight. Na? If you rearrange it, it's actually W is equal to mg. The formula, actual formula is W is equal to mg. You just have rearranged it, Ahmad, and you have made G the subject. So actual formula is W is equal to mg. So the strength of a gravitational field depends upon two properties, depends upon two variables: the mass of the source planet and separation from the source. Two things control the strength of gravitational field. Number one, the first is mass of the planet, and second, how much you are away from the source planet. Now these are the second one. Let me circle here this one. This is actually a general concept. If you are having using a Wi-Fi router and you start moving away, from the router, you will notice that the signal strength is decreasing. The signal strength is decreasing. This means that the signal is inversely proportional to the separation. Signal, yes. Signal is inversely proportional to the separation. So look at this graph as you move away from the earth, like a rocket, like any other source. When you go away from the earth, you take off and go away from the earth, like in an aeroplane, in a rocket, you will see that gravitational field strength decreases. So can you repeat now? What is the definition? What is gravitational field strength?
Is the gravitational force per unit mass.
And what is the concept?
It
It
is
is
inversely proportional to signal.
yes, but it is what is gravitational field strength? It is actually the signal strength. Like when you ask you what is the Wi-Fi signal strength, you can check it and you can tell me 2 bars, 3 bars. So it is actually gravitational field strength is actually what? It is the signal strength of gravity. So we have two main concepts. We stop here and we have missed a class, so we can compensate it tomorrow, or just like whenever possible, we can also do. We can do a double class, but that would be a bit hectic, I know. But we should cover our work because once school will open, it happens every year.